Okay. So we have to, remember, take care of this cosine 2x. I have sine squared. I cannot have cosine 2x and sine squared and still be able to solve. Most probably it's going to be very difficult. But I have a formula or an identity for this that involves sine or sine squared. Can anyone tell us that identity? What is it? Does anyone have that identity? I'm just checking.
Is that 1 minus cosine 2x divided by 2?
So we have for cosine 2x, that is for cosine squared. So let's not confuse cosine squared to cosine with cosine 2x. Cosine squared is one thing, cosine 2x is something else. It happens that this is the same with cosine 2x over 2, but we're talking about this, not about this. So cosine 2x has three different identities. Well, they're not different that much. They are basically the same thing. The first one is cosine squared x minus sine squared x. The next one is 1 minus 2 sine squared x when you change this into sine. And when you change this into cosine, you get 2 cosine squared x minus 1. Only one of these I need in this situation. Which one?
The middle one.
The middle one, because I see that I have sine squared here. So I'm going to replace cosine 2x by 1 minus 2 sine squared. So 1 minus 2 sine squared x plus 6 sine squared x equals 4. 6 minus 2, someone wrote 8. 6 minus 2 is 4. 4 sine squared x. 4 minus 1 is 3. So then sine squared is 3 over 4. When we take the square root, please remember we get plus or minus the square root of 3 over 2. So the positive ones are here for sine, and the negative ones are here. So I have to have 4 solutions. Well, there are infinitely many, but I was specifically said, just give me the solution in one complete rotation. I'm fine with that. So the square root of 3 over 2 has something to do with pi over 3. So pi over 3, pi minus pi over 3, pi plus pi over 3, 2 pi minus pi over 3. So one more time, let me write them in a different color if I can find the red. So this is 1, pi over 3. This is the other. How do I get the other one? Here. 2 pi minus pi over 3. And then I have 2 on this side. So this angle is pi minus pi over 3. And then this angle is pi plus pi over 3. All this piece is pi over 3, this piece is pi over 3, this piece is pi over 3, and this piece is pi over 3. So 0 plus pi over 3, pi minus pi over 3, pi plus pi over 3, 2 pi minus pi over 3. So now let's list them. Pi over 3, pi minus pi over 3 is 2 pi over 3. Pi plus pi over 3 is 4 pi over 3. And 2 pi minus pi over 3 is 5 pi over 3. These are the 4 solutions of this trig equation. Is this okay? What was the other one, Sophie, that you want to look at? Forgive me, remind me, what was it? Any questions on this? Anyone? Anyone? Okay, I just put those in correct order, and I think I'm on 8. Okay, just let me know what you would like to continue with.
The other problem was cosine 2x equals 2 minus 2 sine squared x.
Good. So the same idea, I will replace this by 1 minus 2 sine squared x equals 2 minus 2 sine squared x. These go away. 1 does not equal 2. No solutions. Next question. Anything else that you'd like to go back to? Any other question? Anything?
Can you do
Yes?
one for
Yes, which one?
can you do one for law of sines and law of cosines?
Yes. Any particular problem? Any problem?
For law of cosines, was it one of it was one of the tests, right?
Yes. What is it? Yes, perfect.
It was side A equals 6.
1 second, sorry.
No problem.
So 6,
B is 8, and then C is 9.
excellent. In this case, we cannot use law of sines. We have to use law of cosines. And let's say I start with angle A. 6 squared equals 9 squared plus 8 squared minus 2 times this product, which is 72, times cosine in between. And yes, there was an issue, and I wanted to thank you for asking that. At least in one of your tests, someone performed this operation disregarding the fact that 2 times 72 is multiplied by cosine A. Please do not do that. You cannot separate these two from cosine. So what we do is this. We move this term to the left-hand side. 2 times 72 times cosine A is 81 plus 64 minus 36, because this one goes to the other side. And now I write cosine A equals over 2 times 72. So 81 plus 64 minus 36 over 144. And of course, I need the calculator for this. Don't forget to put parentheses. 81. I don't need a calculator for this, but I just wanted to show. Please use parentheses, close, and divide by 144. And all I have to do is, first of all, change the mode to degree mode again. And now all I have to do is, since it's cosine, inverse of cosine of the previous answer. And I will get the best answer possible by not truncating this. And I get 40.8. So A equals 40.8 degrees. I will repeat, yes, you can use law of sines from this moment on, but why? So I have that this is 40.8 degrees. I will do the same thing for B. 8 squared equals 9 squared plus 6 squared minus 2 times 9 times 6 times cosine b. Do not perform this operation. It would be a terrible mistake. Move this term to this side and move 8 squared to the other. So 2 times 54 times cosine b equals 81 plus 36 minus 64. I should have, you know what I meant to write. So 108. So since I started like that directly, I'm just going to erase it from here. So now this is exactly how I would put it in the graphing calculator. So I have 81, parentheses, don't forget, 81 plus 36 minus 64, close and divide by 108. It was, yes, 108 indeed. I don't even care to copy this number. I just want a second and cosine and the previous answer, close, and this is it, 60.61. So B equals 60.61. Perfect, now I have 180 minus 60.61 and minus that 40.8. Done. That the last angle, which is C, is 78.59 degrees. I specifically didn't want to go through that side-side angle. It's the most difficult one, it's the ambiguous case, and I thought that that would be more difficult than just apply law of cosines twice. Good question. Anything here? Any doubts? Any questions? Anything? Anything else? Any other type of problem that you want to work on? So we looked at this. This, I think, the example, it's exactly the same example you had on your homework. Recursive, the sequence given by a recursive formula. So let me see if I can find that. So you have a 1 equals -4, and the general term is n plus 4 times a, the previous term. And we were asked, I don't like 5, I just want to make it shorter, so I only asked 4 terms. And actually, you already have the first one. So a1 equals -4. But a2, a sub 2, has to be 2 plus 4 times the previous one. -16 plus 2 is -14. Now a sub 3 has to be 3 plus 4 times the previous one. And then the last one, 8 sub 4 equals 4 plus 4 times the previous one. So what do we get here? So 3 minus 56, is it? -53, am I correct? Yes, I think I'm correct. So -53. So this is 4 minus 2, I think I'm correct, -208. So this is the first one, this is the second term, this is the third term, and this is the fourth term. This is just to follow the pattern. So that was the sequence. Anything else? Can you say, I think that if I see such and such problem on the final exam, I may have some difficulties with it. Maybe we should work on another one. Is there any particular, I need to plug in my computer. Is there any type of problem that you say, oh, I think we should do another? Any type of problem?
Can we do another binomial theorem?
Yes, you choose. You choose what you want inside, you choose the power. Yes.
Can we do 2x plus 3y squared and then to the power 4?
Yes. So remember, if it's power 4, I have to have 5 terms. If it's power 2, binomial, I have to have 3 terms. Good. So I find first the original coefficients. 1, 1, 1. I have to stop at 5 terms. 1, 2, 1, 1. 1, 3, 3, 1. 4 terms. Not 5 yet. 1, 4, 6, 4, 1. I found 5 terms. The first coefficient would be 1, the initial coefficient, not the final one. The initial 4, initial 6, initial 4, initial 1. So then, I'm ready. 2x plus 3y squared to the 4th power is 1 times the first term to the 4th power plus 4 times the first term to the 3rd power, but now the second term pops in. 3 plus 1 power 4 plus 6. 2x, it went from 4 to 3, it has to go to 2 now, times 3y squared, it went from nothing to 1, it has to go to 2. 2 plus 2 is 4. Plus 4. 4, 3, 2. The last time 2x appears, times 3y squared, nothing, power 1, power 2, this must be power 3. 1 plus 3 is 4. Last one, plus 3y squared to the 4th power. This is preliminary. Now I have to clean it up. I have to find the real coefficients. The final, I shouldn't say real because I don't even think it's real numbers. I have to find the final coefficients, which I don't have yet. So 2 to the 4th, 16, x to the 4th, x to the 4th. This is the first term. It's carved in stone. Plus 4 times 8 times 3. So 12 times 8, 96. 4 times 2 to the 3rd, which is 8, and times 3. 4 times 3 is 12, times 8, 96. X to the 3rd, y squared. This is done. Plus, I have 6 times 4 times 9. 4 times 6 times 9. 4 from here, from 6, 3 squared, 9. I got 216. X squared, y squared squared is y to the 4th. Plus, this is carved in stone and it's done. Plus, 4 times 2 is 8. 8 times 3 to the 3rd, which is 27. 216 again. X, y squared cubed, copy the base, multiply the exponents. Carved in stone. Last one, plus 3 to the 4th is 81. Y squared to the 8 to the 4th is y to the 8th. Done. Again, I think it's beyond the scope of the course to have more than 4, maximum 5. Because if you understand the pattern for 4, you'll understand it for 10. And it's anything beyond 4 or 5, I think its endurance is not, it doesn't test the understanding. It's just a test of endurance, and I don't like that. Any questions on this? Any questions? Well, although I have seen only black squares this semester, I will miss you.